Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 2.2, Problem 21. This is Section 2.2, Problem 21. It says, find the prime factorization of the number, write repeated factors using exponents. So, we have 600. Seems really big. But you'll see it breaks down fairly quick. So, I don't feel that I need to start with a prime. You can, some people do. The first thing that jumps into my mind is 600 can be made with 6 times 100. That works great. Neither one is prime, but it's a good place to start. Neither one is prime, so I can break each one down a little bit again. So 6 can be written as 2 times 3. 100 you can break down many different ways. What I think of, the first thing I think of is 10 times 10. Many other ways to make a 100, but 10 times 10 is the first thing in my head. Again, let's say you went to 25 times 4. In the end, you just have the same prime factorization. I saw 10 times 10 first. Now, in this row, the 2 will not split anymore. That's prime, so it came straight down with no splitting. Same thing with the 3. It is already prime. It won't split. Each 10, though, can be split into 2 times 5. So the first 10 splits into 2 times 5. The second 10 also splits into 2 times 5. Now, at this point, every number in the bottom row is prime. 2 is prime, 3 is prime. I have 2 again a couple of times. 5 is prime. It shows up twice. Everything is prime, so I've gotten to the end. So as big as this 600 seemed when it started, it broke into primes fairly quickly. So now, I'll write 600 equals, and it's most common to put the primes in increasing order. So first I'll list 2. It shows up in 3 spots, so I'll write that as 2 to the 3rd power times, next I'll put 3, and as I look, the 3 only shows up once, so just times 3. And then 5 shows up 2 times, so I'll put 5 to the 2nd power. And now those are the primes that multiply to make a 600. 2 to the 3rd power times 3 times 5 to the 2nd power.